So this is a video and follow-up to our video demonstration looking at two hypothesis testing two population variances. So in the previous video, what we did is we went in and we looked at the example from white paper 12.1, number 1. I really summarized that information here, and I've changed things up very slightly. So now in this video, what we're going to look at is if we wanted to kind of do the non-preferred method, where we're actually going to be working on kind of this left-hand tail, right? What would we have to do? And again, in the context of BA 254, this might rear its head as like an extra credit problem, just a way to show off. Because again, what we want to do is focus on this right-hand tail based on the geometry of the distribution. But if we did, kind of closing the loop, figuring out how we could actually recognize that there is a possibility of also solving this hypothesis test using kind of the left-hand side of our, or left tail of our F distribution, we can do that. So here what I've done in the null and the alternative hypothesis is I've reversed now the expressway and the back roads. Now again, not strictly required for this two-tailed test, but if we were doing a one-tailed test, it would shift the inequality in a different direction. Our step number 2 is exactly the same. Our significance level is 10%. Our F calculation when we did it prior was 1.653. Now we've, again, flipped numerator to denominator these values. So now we have 3.5 squared over 4.5 squared. So our calculated value now of F is 0.605, all right? We also have to make a modification now to our step number 4. Again, before we had degrees of freedom in the back roads over the degrees of freedom in the expressway. We've now flipped those around. We can go to that same 5% because remember, we still have the same on each one of these tails, the same 5%, all right? Of course, they are not symmetrical, right? They are a very vastly different shape, but basically then the area is still the same. So we have the same 5% table, but now we've had to flip from 8 to 9 to 9 to 8, which gives us a slightly different critical value. Now that does not represent our critical value yet. What we have to do is find the reciprocal of that number. Therefore, we end up around 0.295. It's like 4 and change, but 295 as our critical value. So again, if we were writing this out, this rule would also be slightly different. We would reject H sub 0 now if our F calculated value is then less than 0.295. Of course, we know we calculated our F value at 0.605, so we end up with this same solution, same conclusion as we did before. Do not reject H sub 0. Do not reject the null hypothesis. But one thing to point out is look at how much closer these two values are, of course, than our previous two values. It's just another way to demonstrate that we have to be a lot more careful dealing with kind of the left-hand tail than the right-hand tail.